We're going to solve systems of equations by substitution. So a system of equation is just two equations that work together, and there's a particular answer for x and a particular answer for y that will satisfy both of these equations and make both of these equations true. So in order to find that, we're going to use one of the first and easiest methods, which is substitution. In this case, when you look at these two equations, they're both starting with y equals. So in other words, the variable y is already isolated, and so it makes it easy for us to substitute, because if this expression is the same thing as y and this expression is the same thing as y, we could set them equal to each other. So I'm going to do that. I'm going to take 6x minus 11 equals negative 2/3 x plus 7/3. Okay, so there is a trick. If you don't like fractions, you can get rid of the fractions by multiplying both sides of the equation by the denominator or by the least common denominator. So just to make it easier for people who don't like fractions, we can do that. So we're going to multiply both sides by 3 using the distributive property to go ahead and get rid of those. So 3 times 6, that gives me 18x minus 33. 3 times negative 11 is 33, negative 33, and then 3 times negative 2/3. So if you think about 3 times negative 2/3, you're going to multiply it by 3 over 1, which would give you negative 6. Negative 6 over 3x, and then same thing here, 3 times 7 would be 21, and then the 3 times 1 is 3. So these fractions are going to reduce to integers, to regular easy numbers. So 18x minus 33 equals negative 6 divided by 3 is just negative 2, and 21 divided by 3 is 7. So you can see we canceled out the fractions, and now we just have a regular equation. We have the variable x on both sides of the equation. So solving for x, we just need to get x by itself. So we have to get all of the other stuff on one side and all the x's on the other side. So I'm going to put x on the left-hand side. So my first step will be to move positive 2x from the left-hand side, from the right-hand side to the left-hand side. In order to move it, since it's a minus 2x, I just add it to itself, because if you have a negative 2 and a positive 2 together, they're going to cancel out, and I'm also going to add the 2x to this side. So this cancels out, and now I have 18 plus 2 is 20x minus 33 equals 7. I just bring down that 7. Now it looks a little bit simpler. I need to move also the negative 33, and I can do that by adding 33 to it to cancel it out, to make it 0, which means I also must add 33 to the other side. So 7 plus 33 is 40. So I have 20x equals 40. Now, in order to get the x by itself, I have to get rid of the 20 that's multiplied by it. So I do the opposite of multiplying, and I divide both sides by 20. And it cancels out. It becomes 1x, or just x, and x is equal to 40 over 2, which is 2. So I have my first answer. I have the value of x that satisfies this system. Now I need to find the value of y. So I'm going to use substitution again. I'm going to take this value of x equals 2, and I'm going to plug it into one of my original equations. It doesn't matter which one, but since this top one doesn't have fractions, I'm going to use that. So I'm going to plug in the value of x. So y equals 6x. Instead of x, I'm just going to put 6 times 2 minus 11. And now I just find the value of y by simply simplifying this. So y equals 6 times 2 is 12, and 12 minus 11 is 1. So I have the value of y equals 1 and the value of x equals 2. And the most common way you'll see solutions written is like a coordinate pair. So the x value would be first, and then followed by a comma and the y value. And this 2, 1 means that x is 2 and y is 1. And that also means that if you were to graph these two linear equations, the point 2, 1, that would be the coordinate at which these 2 points intersect. We'll talk about that later with the graphing, but that's how you solve by substitution.